Let's review a couple of ideas before moving on in our chapter for our AP Physics 1. Like things like displacement, distance, velocity, speed, acceleration, those kind of ideas. So here's our example. Coyote starts out from his original position as shown, goes 140 meters east, then 220 meters west, and then 110 meters east. And let's calculate his total distance traveled and total displacements traveled. Okay, pause video and try that. All right, assuming you've paused the video, let's do displacement first. So in displacement, we have to consider directions. So we have 140, and 140 is positive. And then we have a negative 220, and that's because that's a west. And then we have a positive 110. And the net result for that is 30 meters, and that's positive. And then we'll label that east as a result. Okay, now what about the distance? The distance traveled would be the absolute value of all these. So it would be 140, and the negative goes away and becomes positive 220, plus 110. And that gives us a total distance of 470 meters. And we don't have to label that at all, just 470 meters is the total distance traveled. Okay, now what about looking at the average velocity and average speed for Coyote? Well, velocity is going to be equal to the displacement divided by time. So I'll take 30. And let's see what the total time is. We have 6 seconds, plus 4 seconds is 10, plus 5 is 15. So that would be 30 divided by 15. Or simply 2 meters per second. What about the average speed? I'm going to use this as my notation for average speed, absolute value of velocity. Okay, I will take my total distance traveled and divide it by my time. And that's going to come out to be 31 meters per second. Now this one here, the velocity needs a label, and we'll label that east. And our speed does not need a label at all again, because that one has no direction associated with it. So we see there's quite a difference between those kind of calculations, the speed and the velocity. Okay, let's turn to graphs. Okay, we have a motion of a car, and we're going to consider the positive direction is going to be east, and the negative direction will be west, just like our Coyote. Now we could have been north, south, so north is positive, south is negative, but we'll just go east, west. Determine the displacement from 0 to 2.5 seconds, and determine the distance from 0 to 2.5 seconds. Now remember, we have to consider there's a direction with this, so this will be the total displacement traveled is going to be the difference, okay, along this graph. The total distance traveled, however, we have to remember that there is probably a minimum distance that we are starting and going to, and then going to that to something else that has to be added together. It's just an introduction to that. Let's pause the video. Why don't you try that? All right, assuming that you have paused the video, our displacement would have been calculated by doing, well, what's my displacement at 2.5 seconds? I see it's negative 14.25. And I'm going to subtract, what's my displacement at 0 seconds? A negative 20.5. Okay, and that equals 6.25. I'll keep more sig figs this time, and that's going to be meters, and I'll label that as east, because that came out to be a positive number. All right, now what's my total distance traveled? We'll have to consider I'm going from negative 20.5 to our maximum here of negative 25.8, and there all the way back to a negative 14.25. So then I have to consider, well, what's my distance going from this point to this point, and I have to add my distance from going this point, okay, to that point. So let's go ahead and do that. So it's going to be 25.8 minus 20.5, and I'll put that in parentheses, plus, again, a 25.8 minus 14.25. And I'll put that in parentheses. So this is the distance along the first interval to our maximum displacement. And this is from maximum displacement back there. How far did I go through both of those motions? And that equals 16.9 meters. And notice I will not write east or west or anything there, because once again, distance does not have any direction associated with it. Okay, let's continue. Determine the average velocity from 0 to 2.5 seconds. Well, my average velocity again will be displacement divided by time. So 6.25 divided by 2.5. Okay, and that is going to equal 2.5 meters per second east. My average speed, again, I'm just using the absolute value of the average velocity symbol, will then equal 16.9, and that'll be divided by 2.5. And that equals 6.8 meters per second. So that's how we handle dealing with average velocity and average speed on a graph. In our next video, we'll look at instantaneous quantities and some average accelerations.